In 1983, Howard Gardner proposed the idea that there were 7 discrete modalities or intelligences that students could express aptitude or intelligence in. And those are verbal, logical, visual, musical, intrapersonal, intrapersonal, and of course, tactile kinesthetic for our hands-on learners. And since that time, most professionally trained teachers have attempted to create lessons where there was a component that addressed each one of these 7 types of learning modalities. Now, how does that fit into an e-learning or online or computer-based classroom? Verbal, visual, logical, musical, intrapersonal, and interpersonal skills are already being accommodated by millions of teachers worldwide just by using the World Wide Web and the Web 2.0 tools that are available to them. But where do the hands-on kinesthetic learners fit in? The majority of examples that I've seen in practice state something along the lines of kinesthetic learners will be accommodated through the use of keyboard and mouse. Now, to me, that doesn't sound like much of a kinesthetic activity. Consider in 2005, a group of medical research students in Virginia were able to reveal that 75% of students, 3/4, were able to benefit from some type of kinesthetic body-based or tactile touch-based instruction. Now, how can we possibly overlook that when we're designing an e-classroom or instructional online environment? Now, although there are quite a few technologies out there already that allow humans and machines to interact on a much more physical level, the prohibitive cost of those devices is keeping them out of the classroom. I don't think that we'll be witnessing full force feedback exoskeletons in classrooms or 6 degree of freedom joysticks that are mailed to our online correspondence students anytime soon. So what is necessary here is a low point of entry device that can be easily adopted and standardized by the educational content development community. Because without the software support and the developer support, even the best hardware is doomed to failure. So in looking for devices that filled this need, I came across a series of videos with some experiments performed by Dr. Johnny Lee using a very high-power infrared tracking system, which is actually already available and in use in millions of homes across the United States. I happen to have one of those extremely useful and versatile and technologically advanced cameras right here with me. Want to see it? The Nintendo Wii Remote. I use this device to replicate a number of Dr. Lee's experiments, including the low-cost interactive whiteboard and the reflective infrared glove. But the application I found most useful for this little device is to use it almost the way it was intended, except substitute the video game console for a computer attached to an LCD projector. In addition to the Wii Remote, the only other hardware required is about $5 worth of electronic parts that you can use to build your own infrared emitter bar that allows the Wii Remote to track where it is in space. Using the open source software Darwin Remote, I was able to configure the buttons on the remote to simulate mouse clicks and keystrokes. I was able to navigate the computer much like I would with a traditional mouse. Moving the Wiimote allows its built-in camera to track the infrared emitter and subsequently move the cursor on the screen. I tried many different software applications to find ones that would most benefit from this type of interactivity. By far, my favorite was Microsoft's PhotoSynth. PhotoSynth allows anyone with a digital camera to create navigable walkthroughs of anything that you can imagine. By recognizing patterns and details in the photographs, PhotoSynth automatically stitches hundreds of photographs together, creating a seamless experience that has the potential to put traditional virtual field trips to shame. Combined with the Wiimote, PhotoSynth creates a very powerful interactive environment, allowing you to navigate around the images and zoom in on details with close-up photos. Of course, anything becomes more fun when you can put your body into it. Even chess. I tried the chess experiment with my own students one day, and I can honestly say I have never seen 8th graders more interested in the game of kings. The best thing about these Wiimotes as a kinesthetic teaching tool is the cost. For less than the cost of one interactive smartboard for your classroom, you can outfit all of your students with a Wii remote. Their small size makes them perfect for delivering to online students as well, as the emitter bar works just as well on a small screen. Now obviously, kinesthetics in an e-classroom seems like a wonderful thing, but what about those students who like the tactile sensation of being able to touch things and feel things and take things apart? Wouldn't it be great if there was a device that helped them get some tactile feedback from their computer? I've spent the past couple of months working on a haptic feedback device that would allow tactile students to get more in touch with their computers. The device actually takes a familiar form for anybody who's used a computer since 1985. The Power Mouse concept is my attempt at bringing haptic feedback to the e-classroom. Haptics refers to the sense and to the science of touch, through which human beings receive a large portion of their information. The design is based off an experiment done by researchers at Johns Hopkins University, where they measured reaction times when test subjects use a resistive feedback mouse as opposed to a traditional one. The Power Mouse concept, however, incorporates 3 types of haptic feedback to the user's hand based on on-screen stimuli. First, the data is read from a Java applet running on the connected computer, then transferred to this box, which contains a microprocessor that converts the signals into electrical impulses to drive the feedback devices hidden inside the mouse. In the prototype setup, users can receive resistive, vibration, and warm and cool thermal feedback by mousing over colored areas on the screen. Although there's little educational uses for mousing over colored boxes, I believe the potential is huge. Imagine clicking and dragging on an on-screen object that feels heavy, or playing a virtual hot and cold hunt, or maybe even the mouse buzzing in your hand when you're making an incorrect choice. Middle school administrator and e-learning facilitator Carrie Armstrong had the opportunity to try the Power Mouse prototype.
You know, if that drag wouldn't be helpful, they might not always understand the feedback that they're getting from a teacher, especially an ESOL student. The one thing that a lot of e-curriculum is built for are students that are struggling readers, and that this could be a good way to help them keep track of even their fluency, you know, where we talk to kids about their actual rhythm, the way that they're speaking, the way that they're reading. You know, this would be a great pacing tool about dealing with actual materials, and having this to be able to simulate materials could also be a cost-saving measure for schools that are working with, you know, bigger projects, science projects and things where maybe they can't buy all the materials that are needed to simulate some of these bigger projects. When people say, well, what about our students that don't read well on their own, they don't do well without immediate feedback from an actual person? You know, this tool can give them some immediate feedback. It can really broaden that base, so I can't imagine that they wouldn't want to integrate it as quickly as possible.
I hope you've enjoyed this look at what could possibly be the future of e-learning, and whether that future contains power mice or Wii remotes or something like or I hope to be a part of it.